Hello friends, this is the second session on time, speed and distance. In this we are going to talk about how to find out the time taken when a train is crossing an object. We are also going to discuss the upstream, downstream motions, the circular motion, etc. So let's first, before starting with the other things, let's first do a quick recap on what we did in the first session on time, speed and distance. So first thing that we did was the definition of speed, which is speed is equal to distance by time. So this is the most important concept, the relation between speed, distance and time, which is being used in finding out all the different things. So this is the first thing that we did. Then we talked about average speed. So average speed is different from normal speed in the sense that this is given by the total distance traveled divided by the total time taken to travel that distance. So this gives us the average speed. Then we talked about relative speed. Relative speed is the speed of one object with respect to the other object. So we said for objects moving in same direction, relative speed is given by v1 minus v2, and objects moving in opposite direction, that could be either moving towards each other or moving away from each other, the relative speed is given by v1 plus v2. Right, so this is what we covered in the first session on time, speed and distance. Let's now move on to a concept of train when a train is crossing a point object. Right? When we say point object, it could be a man standing, it could be a pole, it could be a tree. So, and a train is crossing it. So how much time does it take for a train to cross a point object? So let's assume that this is the point object. This could be a person, tree, pole or anything, some vendor, anything. So this is a point object. Now a train is coming from here. It comes closer to A and then it crosses A. So we are talking about the time that it takes to cross the point A. What does that mean? We are saying that at this point, at a time when the train beginning end of the head of the train hits this point A, to the time the tail of the train is at point A. This is the time taken for the train to cross this point object, right? So if this is the length of this is the train, if it has to cross A, so starting when the beginning of the train is at point A and then it crosses and the beginning is now at some other point and this end of the train is now at point A. So this will be the time taken. So now just using the relation between time taken and speed and distance, we can say time taken will be, distance is how much? Just the length of the train. That is the distance that it has to cover, divided by the speed of the train. So this is the time taken by a train to cross the point object. Now, if the object that it has to cross is not a point object anymore, now if it has a given length, say for example, this is the object A, it has a length L. Now the train coming in this direction has to cross it. That would mean that at this point, the head of the train it continues to move, and it moves out such that the tail of the train is at now this point, right? So this is the distance that the train has to travel. So how much is the distance that it has to travel? It is the length of the train plus this L, small l, which is the length of the object, right? So that is the distance the train has to travel. So we'll say time taken will be given by length of train, let's take it as capital L, plus length of object divided by the speed of train, because the object is still stationary, right? So object is not moving. So we're talking about the length of train plus the length of the object is the distance that it has to travel with its speed, which is the speed of the train. What could be the typical example of this is, supposing the train is crossing a platform or the train is crossing a bridge. So what will be the time taken by the train to cross a bridge or a platform is the length of the train plus the length of the platform or bridge divided by the speed of the train. So we can say L plus small l divided by speed of the train. So this is the time taken for crossing an object of length, a stationary object of length L. Now what will happen if the train is crossing a moving object? So what does that mean? Now supposing we have this object, and now we are taking, it could be an object of length L, or it could be a point object. So we have to consider both the cases here. And this is also moving and the train is also moving, which could be either in the same direction or in the opposite direction, right? So now let's first of all take the case of when the object is moving in the direction which is same as the direction of train. If we take that, what will be the time taken? Now we understand that the distance that it has to travel is the length of train plus the length of object, and in this case a typical example would be a train crossing another train moving in either the same direction or an opposite direction. Now this has to be divided not by the speed of the train, it has to be divided by the relative speed now, right, of the train and object. So now what is the relative speed? Now first of all, length of the train is capital L, length of the object is small l, divide by, we said that the relative speed when the two objects are moving in the same direction is v1 minus v2. So we can say v train minus the v object. So this will give you the time taken when they are moving in the same direction. Now let's take the case where the object and the train are moving in different direction. In this case, the time taken will be again equal to the distance travelled, which is nothing but the length of the train plus the length of the object divide by again the relative speed. So what will be the relative speed when they are moving in opposite direction? This will be v1 plus v2, which is vt plus VO. Vt is for the velocity of speed of train, and VO the speed of the object, right? I am using the term velocity and speed interchangeably, although they are not same, but we are just talking about the value here. So I am using these terms interchangeably. So it is actually the speed of the train plus the speed of the object. So this is the time taken when the train and object are moving in opposite directions. Now let us talk about the downstream and upstream motion. What does the term downstream motion mean? Downstream motion means that the object is moving in the same direction as the motion of the medium. Now supposing a boat is moving with the direction of the stream, right? So this is the downstream motion. Or supposing we are walking or cycling along the direction of the wind, that is called the downstream motion, same direction as medium. Upstream motion is just the opposite of this, which means that we are moving in the opposite direction to medium. So again, supposing the direction of the stream is this and the boat is moving in the opposite direction, or the direction of the wind is this and we are walking or cycling in this direction. So this is the upstream motion. Now let's find out the speed of the object in both the cases, right? So original speed of the object, let's call it VO, and we say speed of medium, which could be wind, stream, or anything else for that matter, this is Vm. Now we'll say effective speed. What will be the effective speed in case of downstream motion? So what do we feel if we are moving? Which one is easier to achieve, when we are moving along with the medium or when we are moving opposite to the medium? We know that it is easier and normally faster to move along with the medium. So that would mean that the effective speed is basically the addition of the two. So let's call it Vd here. V downstream will be addition of the speed of the object and the speed of the medium. Now effective speed in case of upstream motion, let's call it Vu. This will be equal to VO plus VO minus Vm, right? Because here the medium is opposing you, right? If you're moving against the medium, it is trying to oppose you, so it will slow you down. So Vu becomes VO minus Vm. Now supposing Vd and Vu are given to us, right? So can we find out the speed of the object, the original speed of the object and the speed of the medium? Yes, we can do that. If we know these two relations, then we know that VO, the speed of the object in still medium, when the medium is not moving, will be given by half of Vd plus Vu. We can simply see that if we say, let's say this is equation number 1 and this is equation number 2, if we simply add them, Vd plus Vu becomes twice of Vo. So Vo will be equal to half of Vd plus Vu. And Vm, if we subtract VU from VD, because VU is definitely lesser than VD. So we subtract, we get that is equal to 2 Vm. So Vm becomes half of Vd minus Vm. So if any two out of these four, if any two speeds are given to us, we can find out the other two. Right? So where are they used? Now supposing we are, as I mentioned the example of, I am cycling from place A to place B and I am cycling back. So I know that if there is no wind, I cycle at a specific speed VO, right? But then I know that today is a windy day. So if I move along the wind, A to B is the direction of the wind, for example. So if I move from A to B, I'll go faster, while when I come back, I'll take more time. So I can find out how much will be my effective speed, how much time will I take to go, and how much time will I take to come back. Similarly, if a boat is going in the stream, so how the motion of the stream impacts the motion of the boat and how much time it will take can be calculated using this concept of upstream and downstream motion. Now let's take an example of, now let's first of all understand what is circular motion. Now all of these things we'll understand with the help of examples in a separate session. We'll take examples about all these: circular motion, downstream, upstream motion, the train crossing, and these. So we'll understand more about those with the help of examples in that session. Now what is circular motion? Of course we have this circular, it may be a track, it may be a road, it may be anything. So we are moving along this, we are moving in a circular motion. So this circular motion concept deals in finding out the time of meeting two objects which may be moving on this circular path, right? So that is the kind of problems that we solve using this concept. Now supposing we take this point A and two people start from the same point at the same time in the same direction or opposite direction. So one possibility is that one person starts moving like this and the other person starts moving like this, right? Let's use different color for that. Right? So now we are taking the example of opposite direction. Now if this person takes y time and this person takes x time to return back to their starting point, then they will definitely meet somewhere in between. It could be, the point could be here, the point could be here, the point could be here, but they'll definitely meet because this person is going to come back to point A and this person is going to come back to point A, but they're moving in opposite directions, right? So they are going to definitely meet at some point. So the two people meet at this. Now the first time when these two people will meet will be given by LCM of x and y. Okay. So now if the two people, now if this is the circular path and if the two people are moving in the same direction, again with different speeds x and y. Now again what will happen is the first time that they meet, now supposing this time this person has started and this person has started again at the same time from the same point, they will meet, and that is also given by the LCM of these. Now let's take an example. Say one person, let's take this person to be P1, he takes 10 minutes to complete, right, to come back to its position, and P2 takes 15 minutes to complete the round. So the LCM of these two is 30 minutes. Now in 10 minutes this first person has completed the round. This first person who is moving in this direction has completed the round in 10 minutes, and this person is taking 15 minutes to complete it. So when will they meet? They will not meet in the first round. They will meet again at the point A after 30 minutes, if we see, when the first person has already completed 3 rounds and the second person has completed 2 rounds. So that is when they'll meet. So this is how we calculate it. And the same formula can be applied if there are more than 2 objects. Right? So when will all of them meet at one point? We will again find out using the LCM approach. Right? So this is how it happens. If 2 people start from the same point at the same time in the same or opposite direction along this circular track, and they take, say, X and Y time to come back to their starting point respectively, then the first time when these 2 people meet at the starting point will be given by the LCM, right? The first time they meet at the starting point. Right? So supposing now if they are moving in the opposite directions. Now in 10 minutes the first person completes, and in 15 minutes the other person completes. So till the time they'll come back to the point A only at the LCM of X and Y. At no other points will the 2 come together. Right? If X is coming at every 10th minute, Y is coming, the person P2 is coming at every Yth minute, which would mean that both of them will reach there only at the LCM of X and Y. So the first time they meet at the starting point is the LCM of X and Y. Now, another thing about circular motion is, if 2 people start from the same point at the same time, and they may move in the same or opposite direction along that circular track, and they move at 2 different speeds, say m km per hour, this is for P1, and P2 is n km per hour. We have this circular path. Both of them start from this point A. They could either move in the same direction or they could move in the opposite directions. So they're starting from the same point at the same time. Directions may be same or opposite, and they're moving with these 2 speeds, m km per hour and n km per hour. Then the first time when they meet, the first time they meet anywhere on the path, on the track. This is given by the circumference of track divided by their relative speed. Now let's first take an example when they are moving in the opposite direction, right? So if they're moving in opposite direction, then, and this person is moving at m km per hour and the second person is moving at n km per hour, the time at after which they meet is time t. So the distance that they've traveled is mt plus nt, and that has to be equal to the circumference of this track. So t will be given by circumference divided by m plus n, and m plus n is nothing but the relative speed when they're moving opposite to each other. Right? Now if they move in the same direction, then they would meet when one person, so this is opposite direction, now if they are moving in same direction, they would meet when one person would have covered one more circumference than the other. Obviously, now if they are moving in the same direction, at least one of the two would have definitely covered this whole circumference and started the second round when he will cross over the first person who's moving at a lesser speed. Right? So now in that case, let's first of all assume m is greater than n. Right? One has to be greater than the other. We have to assume that. So in time t at which that they meet, the distance will be mt traveled by this person p1, and nt, the distance traveled by t2, and that will be equal to circumference. Right? Because the first person, this person which is moving at a higher speed, has already covered one more round. So the difference between the two would definitely be the circumference. So t would be equal to circumference divided by m minus n, and this m minus n is again the relative speed in case of motion in the same direction. So we can easily conclude that the first time that they meet anywhere on the track will be given by circumference of the track divided by the relative speed, but the first time that they meet at the starting point will be given by the LCM of the two times that they are taking to come back to their starting point. So this is how we calculate the different times, and this is a very essential concept which is used in different day-to-day scenarios, which we are going to see in another session where we'll cover the examples on the same. So friends, you can visit us at our Cool Smart Learning website, and you can subscribe to our YouTube channel to get more updates on the new sessions. Thank you.